because site means cell. So sitting in there is this great big huge nucleus cell. And it just gets to sit there. Think of Jabba the Hutt, okay? And with Jabba the Hutt and how he just kind of sits there and stuff just kind of flapping all around, all right? That's sort of how this megakaryocyte's doing. It's kind of sitting there in these little spicules, these little trabeculae of the spine of the bone marrow, and as the blood flows by, stuff breaks off, and that's a platelet. Is that not cool? So if you think about it just sitting in the spongy bone, as the blood flows by, stuff just kind of breaks off. Here's Jabba, okay? And then little pieces of the cytoplasm and everything just kind of break off.
Do they ever like get smaller or like run out of pigments or particles to get
There, well, see, once again, they will get produced. So in other words, even though that cell might be there, never really looked up the lifespan of one, but I'm sure it has one. I'm sure it has a lifespan. And therefore, it would come time and the body give rise to another one under normal conditions. All right? So it kind of breaks off. However, that cell that I'm referring to is like Jabba the Hutt. It's complex. So we're going to find lysosomes, mitochondria, microtubules, microfilaments, granules, open chemolecular system, and that platelet. But I have no nucleus. It is simply the little fragment with all this other stuff that exists within it. So our platelets, even though not a full cell, they got a lot of stuff in there. Lysosomes, which we already understand, can break stuff up. Mitochondria, because they need energy. Microtubules, because we got to transport stuff in and around that cell itself. Microfilaments, being able to collapse and reform back up. Granules, meaning they're going to have those little pockets of the lysosomes. And then we call it an open chemolecular system because there's nothing that is within within the structure of what we think of as having nucleus, endoplasmic reticulum, and so forth. So what do the platelets do? This is what they can do. Secrete vasoconstrictors. This time, meaning we want to constrict the blood vessel. Form a temporary platelet plug. And I'll explain that in a minute. Secrete what is termed procoagulants. These are my clotting factors. For example, a person with hemophilia will be either one or more of the clotting factors that we have can either not function or not be present. So one of the things that they can do is the platelets, they can secrete my clotting factors, also known as the procoagulants, in favor of clotting the blood. Initiate formation of a clot dissolving enzyme. After platelets have done their job and we have stopped the flow of blood and tissues can begin to heal, we can't have the clot stay there indefinitely. So they have the ability at the time of the healing to begin to say, it's got to break down. So they can release the clot dissolving enzymes. They secrete chemicals. Now look what they attract. They attract neutrophils, which are for what? Bacteria. And monocytes, which are for what? Viruses. If I have breached my body to the outside world, two of the biggest that I'm going to need to fight off, trying to invade me, are bacteria and viruses. So they actually give off chemicals that say, y'all need to get here quick. And that's what they do. They internalize and destroy bacteria because they have lysosomes. Secrete growth factors to help stimulate mitosis. What is that? My cells increasing in number, which means at the area of the breach, I can generate nice new cells. And, okay, mitosis in the fibroblast, okay. Do you guys remember what the fibroblast might do? Give rise to fibers. If there has been a breach, I have breached my blood vessel and other tissues, possibly, like if I'm bleeding through the skin, okay? And repair requires those fibers. But remember I said we cannot have them flying around in whole in our bloodstream. So we have the little protein called what? Do you happen to remember the name of that protein? In my blood, I have a little protein moving around. I think it's on the tip of your tongue. Fibrinogen, which can give rise to the fibers. And what does a blast do? Gives rise, creates. So then wouldn't it stand to reason that I would need that fibrinogen to begin making a fibroblast so that I can begin to generate the fibers to help the tissues repair? Ta-da! Platelets have the ability to help with that. Their production, it is termed thrombopoiesis because the platelets are going to have this really cool protein that they got to deal with called thrombin, which comes from the liver. So that'll stimulate them. Whoa, hold up, time out. Why would a protein from the liver be able to stimulate platelet production?
Doesn't it store things? It just like stores something.
Well, let's think of it this way. What organ stimulated production of my red blood cells? My kidneys, because my kidneys could determine what level in my blood.
Awesome.
Oxygen. So if oxygen was low, it secreted erythropoietin, which stimulated red blood cell production. Now for my platelets. I have to involve the liver. There's a reason why. Like I said before, we don't really say the liver is part of this, this, or this. We say the liver is part of all of these different systems. So one of them, circulatory, because the liver, oh, and wow, okay, the amount of blood it's going to receive, okay, is huge. The structure of it can actually recognize platelet count. And therefore, higher, if it's high, it will promote their production. Does that make sense? Platelets only live a short amount of life because they have a lot to do and they are tiny, okay? So usually once they're called up to do their job in any of this, okay, they tend to be like done. So in this process of hemostasis, basically the cessation of the blood flow at a time when something has been breached, meaning a broken vessel. Not, like I said, hemorrhaging is a totally different issue. But under normal conditions, the process has basically three mechanisms, three steps, so to speak. The first step, vascular spasm, just like the name implies. If a vessel has been breached, broken, it creates like a spasm. Now, once a vessel is broken, these vessels are smooth muscle, all right? We don't control their activities. All right, remember this is under the control of the autonomic nervous system. So, broken vessel, there's an injury to the smooth muscle itself. And that's going to start a series of reactions occurring. And one of the things that tries to happen is it tries to constrict because it has been injured. Now, platelets, if this is the site of my injury, platelets are moving through the blood all the time. So are the other components of the blood. They're trying to show the red blood cells. The spasm that occurs, that vessel breaks and it goes, ugh. Its goal, try to maintain my blood flow, keeping it in the body, in the vessels, until the other two mechanisms can work. So once the vessel is broke and it goes, ugh, okay, the next step, create the platelet plug. Just like the name implies. Our blood vessels, which they're trying to show here and here, I keep trying to point out fibers are present in their structure. We've got the three fibers, collagen, elastic, reticular, okay? When I broke that blood vessel, it exposed the fibers.